Hello, this is Mrs. Baxley, and today I want to teach you about pH. Now, you've known about pH and the pH scale for a number of years, but I want to show you today where it came from and what it really means. One thing I always wondered with pH is, why does an acid have a low pH, 0 to 7, but a base has a high pH, over 7 and up to 14? It seems to me that pH, if it's an acid, it should have a bigger number instead of a littler number. Well, there's a reason for that. We're going to look at that. One thing I kind of look at here, I've tried to research where the term pH came from. And some places I see the potential of hydrogen or the power of hydrogen. I really don't know if either of those is right, but both of those kind of make sense and help me understand a little bit about pH. Now, when we look at the H, we're going to consider H+. And a way to write the concentration of something is to put brackets around it. So the concentration of hydrogen ions in a solution is what actually leads to the pH. Now here's an interesting thing. With a pH of 1, the concentration of hydrogen ions is, in fact, let me move this down a little so we can just kind of make a chart. With a pH of 1, the concentration of hydrogen ions is 1 times 10 to the negative 1 moles of hydrogen ions per liter of solution. With a pH of 7, the concentration is 1 or 1.0 times 10 to the negative 7th. A pH of 0, it is 1.0 times 10 to the negative 0th, which is the same thing as 1. This would be 0.1. You notice here this would be 1, 2, 3, 4, 5, 6, 1. So do you notice as we go down, as we increase each pH by 1, we decrease the concentration of hydrogen ions by 1/10. So you could actually do this for the entire pH scale. Now when you get to 14, you notice this is 1.0 times 10 to the negative 14th, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is this much. So now you can see why this pH has a much, much less concentration of hydrogen ions than this pH. Even a base has some hydrogen ions in it. It's in water, and water self-ionizes, and water has some H+ ions and some OH- ions. But acids have more H+ ions, and bases have more OH- ions. Now another interesting thing I want you to see here is if we look at the pH of 7, you see this number right there? That's where the pH comes from. This number right there, that's where the pH comes from. This number right there, that is where this pH comes from. And this, in order to do calculations with this or figure out where it came from also, we're going to use the logarithmic scale or the log function on your calculator. Don't worry if you're not good with logs. All you need to know is how to plug it into the calculator. Now looking at this illustration of the book is another way for us to kind of understand a little bit better about pH. Again, as I mentioned in the last segment, if you look at the value in the exponent here, that corresponds to your pH. And I also mentioned that there are some OH- ions in every solution as well. And an interesting thing here is we also have a thing called a pOH. The pH is the concentration of hydrogen ions. The pOH comes from the concentration of OH- ions. And if you look at a neutral solution, it has an equal concentration of H+ and OH-. If you were to add the pH, here it's 7. Sorry, I meant that to be a highlighter. And here, the pOH is 7. If you add those together, you get 14. if you go to a pH of 12. pH is 12, the pOH is 2, total 14. The next thing I want to consider then is how can we find the pH if we know the concentration of the hydrogen ions? Well, this is a graphic from your textbook, and let's just consider a couple of concentrations. Let's say the concentration of hydrogen ions is 1 times 10 to the negative 8th. What is the pH? Well, now if you consider what I've showed you on the last slide, it's pretty easy. You just look at this and it's going to be 8. The pH is 8. If I told you the concentration of hydrogen ions is, let's say 1 times 10 to the minus 2, again, easy, pH equals 2. What if I said the concentration of hydrogen ions is 0.0001? Well, we could change that into scientific notation, and that is 1 times 10 to the negative 4. So that's going to be a pH of 4. To put this in a calculator, you're going to have to take the negative log, and then you put your number of the concentration in there. So you're going to have to find your particular calculator, and I want you to try that for each of these three numbers. For the top one, I want you to put in negative log of 1.0 or 1 times 10 to the negative 8th. Now, if you're using our class set of calculators, the way you would do that is negative log, and if you think about it, 1 times 10 to the negative 8th is 1 times second EE, because remember that's an exponent, negative 8. So these are the buttons you would push. Negative log of second EE, negative 8. And when you put equals, then it's going to give you the number 8. You're going to have to find out how your particular calculator works for this. Once you figured it out, and you're like, well, this is too easy. I can do this without a calculator. Well, not always, because what's going to happen is sometimes your concentration isn't going to be exactly 1 or exactly 7. And if your pH is a decimal, then it came from a different type concentration. So for instance, if your concentration of hydrogen ions was 2.3 times 10 to the negative 4th, well, the pH is not 4. It's going to be somewhere close to 4, but not exactly 4. So you're going to have to put in your calculator negative log, and if you were using the class set of calculators, you would put 2.3 second EE minus 4. And you put an equal sign, and then it's going to give you what your pH is. Now you can also do pOH is the exact same way using the OH minus concentration, but we're not going to be worrying about any of those right now. And again, notice that the pH plus the pOH equals 14. Okay, if we were to do the equation that you see up above here, the answer you should get in your calculator would be 3.6. That's your pH. Now don't worry about sig figs with this. Let's just go ahead and plan to round it to the tenths because logarithmic significant figures are different than using other things, so I don't want to get into that. But again, you notice that the pH is close to the 4, but it's not exactly the 4. It is actually a decimal. So now that we've learned how to find the pH, if we know the concentration of the hydrogen ions, and again, this is the formula, you're going to do negative log times the concentration of your hydrogen ions. What if we know the pH and we want to find out what the concentration of hydrogen ions is? Well, we're going to do the reverse of this, and we're going to end up having to do the anti-log. And again, don't worry if you don't know exactly what that means. It's kind of like doing the operation backwards. And I'm just going to show you how what the formula is and how to plug it into your calculator. In the school calculators, the way you do the anti-log is you would do second, that's the button, log of negative, and then whatever your pH is. So the antilog is also 10 to the x, and where x is your pH. So the second log of you want this to be the negative pH, because if you have 1 times 10 to the negative 2, you're going to have to put the negative with a pH after it. So for instance, if we have a pH of 4, then you could easily tell that the concentration of hydrogen ions is going to be 1 times 10 to the negative 4th. So those are easy if there are even numbers. But to put it in your calculator, you would do second log negative, now not the minus sign, but the negative sign, and then you would do 4. And it would end up, when you put your calculator in scientific notation, it would say either 0.0001 if it's not in scientific notation, then change it to scientific notation, and you would get 1 times 10 to the negative 4th. Again, if your pH now is a decimal, let's say your pH is 6.2, then I'm going to put in second log negative 6.2 equals, and I get a concentration of hydrogen ions of 6.3 times 10 to the minus 7th. Now you notice the number 7 is close to 6.2, so this makes good sense. This would be our answer. So that's all there is to these two problems. You've got two formulas. You've got the pH is the negative log of H plus, and then reverse if you're trying to find the concentration of H plus. Let me get a black pen here. Concentration of H plus. That's going to be the second log, or the antilog of the negative pH. That gives you enough information to where you can solve all the problems in the homework. That's all the new information we're getting for this unit. Thanks so much, and take care.